Welcome to Space Explorer 2024. Imagine a time when there was nothing. No stars, no planets, no galaxies, just an infinite void of darkness and silence. No space, no time, no matter. It was a state of absolute nothingness, a blank canvas waiting for the first stroke of creation. Then, about 13.8 billion years ago, everything changed. In an instant, a singularity, a point of infinite density and temperature erupted. The universe exploded into existence in a massive burst of energy known as the Big Bang. This was not just an explosion of matter but an explosion of space and time itself. The Big Bang wasn't an explosion in the traditional sense. It was more like an expansion, a rapid stretching of space and time itself, where every point in the universe moved away from every other point. As the universe expanded, it cooled, and energy began to transform into matter. This cooling allowed for the formation of subatomic particles, the very building blocks of the universe. As the universe continued to expand and cool, these particles combined to form atoms, the simplest elements like hydrogen and helium. These atoms would later come together to form stars and galaxies. Tiny particles formed the building blocks of everything we see around us. These particles, through the force of gravity, began to clump together, forming the first stars and galaxies. Over millions of years, these particles came together, drawn by gravity, to form the first stars and galaxies. These stars would go on to create heavier elements through nuclear fusion, elements that are essential for life. The universe was a vast and ever-evolving place, a cosmic dance of creation and destruction that ultimately led to our own solar system. From the remnants of ancient stars, our sun and planets were born, setting the stage for the emergence of life. Billions of years after the Big Bang, in a quiet corner of the Milky Way galaxy, a giant cloud of gas and dust drifted through space. This cloud was not just any ordinary collection of particles, it was a nebula, a vast and diffuse collection of material that had been ejected from stars that had long since ended their life cycles. This cloud, called a nebula, was made up of remnants from long-dead stars, the ashes of previous generations of stars scattered across the cosmos. These remnants included elements like hydrogen, helium, and traces of heavier elements, all floating in a delicate balance. Something disturbed this peaceful cloud, perhaps the shockwave from a nearby supernova explosion. Supernovae are powerful and cataclysmic events that occur when massive stars exhaust their nuclear fuel and explode, sending shockwaves rippling through space. This disturbance caused the cloud to collapse in on itself, pulled together by its own gravity. As the cloud contracted, the gravitational forces at play became stronger, drawing the gas and dust closer and closer together. As the cloud contracted, it began to spin faster and faster, like a figure skater pulling in their arms. This increase in rotational speed was due to the conservation of angular momentum, a fundamental principle of physics. The center of the cloud grew hotter and denser, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. Nuclear fusion is the process by which atomic nuclei combine to form heavier nuclei, releasing vast amounts of energy in the process. This was the birth of our sun, a giant ball of burning hydrogen that would become the center of our solar system. Over millions of years, the sun's gravity would pull in more material, forming the planets, moons, and other celestial bodies that orbit it today. The sun's birth wasn't the end of the story. In fact, it was just the beginning of a much grander tale that would eventually lead to the formation of our home planet, Earth. The cloud that formed the sun still had leftover material gas, dust, and icy particles. This vast cloud, known as the solar nebula, was a chaotic mix of elements and compounds swirling in the vastness of space. These remnants swirled around the newborn sun, forming a disk of debris. This rotating disk, known as the protoplanetary disk, was the nursery for the future planets, including Earth. Within this swirling disk, tiny particles began to collide and stick together, a process called accretion. These microscopic collisions were the first steps in a long journey of planetary formation. These clumps grew larger over time, pulling in more and more material with their increasing gravity. As they accumulated more mass, their gravitational pull became stronger, attracting even more particles and clumps. Over millions of years, these clumps grew into planetesimals, the building blocks of planets. These small, rocky bodies were the seeds from which the planets would eventually grow. The planetesimals continued to collide and merge, eventually forming the planets we know today. Through countless collisions and mergers, these planetesimals coalesced into larger bodies, giving birth to the planets in our solar system, including Earth. The early Earth was a very different place than the planet we know today. Constant bombardment by asteroids and comets generated intense heat, melting the planet's surface into a magma ocean. During this chaotic period, a Mars-sized object is believed to have collided with Earth in a cataclysmic event. This impact ejected a massive amount of debris into space, which eventually coalesced under its own gravity to form our moon. This giant impact hypothesis explains many of the moon's unique characteristics, including its composition and its relatively large size compared to Earth. The breath and water of young Earth. As Earth cooled, volcanoes erupted, spewing gases from the planet's interior into the atmosphere. These gases, including water vapor, carbon dioxide, and nitrogen, formed Earth's early atmosphere. Over time, the Earth cooled enough for water vapor in the atmosphere to condense and fall as rain, forming the first oceans. These early oceans were likely acidic and hot, but they provided the perfect environment for life to emerge. Life finds a foothold. The exact origins of life on Earth remain a mystery, but scientists believe that life arose from non-living matter through a process called abiogenesis. This process, which likely occurred in Earth's early oceans, led to the formation of simple, self-replicating molecules. Over billions of years, these simple life forms evolved and diversified, eventually giving rise to all the plants and animals we see today. A planet of constant change. Earth has been constantly changing throughout its 4.5 billion year history. Continents have shifted, mountains have risen and eroded, and ice ages have come and gone. Life itself has shaped the planet, from the oxygen we breathe to the very rocks beneath our feet. Earth's history is a testament to the power of geological processes and the resilience of life in the face of change. A blue marble in the vast cosmos. Today, Earth stands as a beacon of life in the vastness of space, a blue marble teeming with diverse ecosystems and billions of living organisms. Our planet's unique combination of factors, from its distance from the sun to its active geology, has allowed life to flourish. As we continue to explore the universe, we gain a deeper appreciation for the rarity and preciousness of our home planet.